Hey everyone, and welcome to this explainer. If you're tackling grade 12 physics right now, you already know we spend a ton of time talking about forces. Things pushing, pulling, colliding, accelerating, all that good stuff. But today we're going to look at something completely different. We're going to explore this fascinating, almost magical mystery of electromagnetism that results in absolute silence. We're diving into the field of a charged spherical shell, and honestly, I promise you, by the end of this, you're going to see why the physics hiding right inside everyday objects is literally extraordinary. All right, let's jump straight in. Okay, so I want you to start by just picturing a hollow metal sphere. Kind of think of it like a thin steel mixing bowl, but perfectly round and just floating right there in empty space. Now, imagine we charge it up. What actually happens? Well, because the like charges repel, every single tiny bit of that electrical charge just rushes outward. They absolutely hate being close to each other, so they want to get as far away from one another as physically possible, spreading out completely evenly over that outer surface. It's exactly like people in a super crowded room all suddenly pushing outward toward the walls until everybody is perfectly spaced out along the edge. Now here is where things get really wild. Let's say we take a tiny invisible test charge and we just drop it outside of our charged sphere. Just as you'd probably guess, it feels a force. Depending on what kind of charge it is, it gets shoved away or pulled right in. It's clean, it's totally predictable, and honestly, it acts almost exactly like gravity. It feels as if every ounce of that charge were perfectly concentrated right at the dead center. But here's the massive twist. Take that exact same tiny test charge and slip it inside the hollow shell. Suddenly, nothing. Absolutely nothing happens. There's zero push, zero pull. There isn't even a tiny hint that the massive spheres surrounding it is charged at all. It is just completely, totally dead still. I mean, take a second and really let that sink in. How on earth can a highly charged object completely surround you, literally encasing you in electrical energy, and yet do absolutely nothing to you? It feels like a total paradox, doesn't it? You're sitting inside a sphere of glowing, highly active electrical charge, but you experience absolutely zero force. No way, right? Well, to solve this mystery, we have to look at what I think is one of the absolute most beautiful concepts in all of physics. And that concept is symmetry. Seriously, symmetry is the completely quiet hero of our story today. Think of symmetry as just this perfect, flawless balance. Like, imagine you're standing in the exact center of a massive crowd of people, right? And every single person throws a rope around you and pulls on it with the exact same amount of force. What happens to you? You don't move a single inch because you are perfectly balanced in literally every direction. All those massive pulls just completely cancel each other out. So let's break down how this actually works on a physical level. When you're hanging out inside that shell, every single bit of charge on that outer surface actually is pulling or pushing on your little test charge. Those forces are totally real, but for every tiny pull in one direction, there is a perfectly equal pull coming from the exact opposite side of the sphere. The sphere is just so ridiculously balanced that these forces instantly neutralize one another. So the really crucial takeaway here is this: the net electric field inside the shell becomes zero. And not just at the dead center either. It's literally zero everywhere inside that hollow space. And listen, this is definitely not just some lucky fluke. Okay, let's dive into the intuition behind this using a really fundamental rule you've got to know: Gauss's law. Now, don't stress about heavy math or crazy equations right now. Conceptually, Gauss's law is just a simple, elegant rule that connects the electric field with the amount of enclosed charge. It basically just tells us that the electric field passing through an imaginary surface is directly proportional to the total amount of charge completely trapped inside that specific surface. So, let's see how this brilliant rule completely solves our mystery. First, imagine drawing an imaginary spherical bubble entirely inside that hollow shell. How much charge is trapped inside your little bubble? Yep, zero, because all the actual charge is living purely on the outer skin of the metal shell. Since the enclosed charge is zero, and the whole system is perfectly symmetrical, Gauss's law guarantees that the electric field must be exactly zero at every single point inside. But step outside the shell for a second. If you draw your imaginary bubble around the outside, suddenly it encloses the entire charge of the sphere. So out there, the field is super strong when you're close, and it gets predictably weaker as you move away, falling off as 1 over r squared. The shell basically hides its true hollow shape from the outside world and completely pretends to be a single solitary point charge right at its center. So, you might be wondering, why does any of this actually matter? Well, because this quiet emptiness inside a charged shell isn't just some neat little math trick to help you pass a physics exam. It's actually a highly practical, genuinely life-saving phenomenon called electrostatic shielding. Basically, by creating a conductive shell, we can engineer this perfectly protective silent zone, a totally empty space where all that crazy external electric chaos just literally cannot enter. Let's take this right into the real world for a second. Have you ever heard that if you're caught in a car during a massive thunderstorm and lightning strikes your vehicle, you're totally safe? Well, it's absolutely true. And why? Because the metal body of your car acts exactly like our charged spherical shell. That huge surge of electrical charge from the lightning stays entirely on the outside surface of the car, leaving the inside, where you're sitting, as a perfectly calm, zero-field silent zone. And we use this exact same trick every single day to protect highly sensitive computer electronics just by safely tucking them inside protective metal enclosures. It's pretty amazing. So the next time you're staring down a tricky exam question, I really want you to remember this simple analogy. A charged spherical shell is basically like a perfectly coordinated crowd. Outside, it acts like one massive, unified source pushing you around. But inside, it perfectly cancels itself out into complete and total silence. You really don't have to just memorize drive formulas here. If you can clearly visualize that coordinated crowd pushing outward and perfectly balancing itself on the inside, then you have absolutely nailed the intuition behind Gauss's law. We've seen today how something as simple as symmetry and Gauss's law can take a completely chaotic electrical storm and turn it into absolute stillness. But man, it really makes you wonder, doesn't it? If a simple hollow metal shell can create perfect silence right in the middle of electrical chaos, what other invisible shields are hiding out there in the physics of our universe? Definitely something to chew on as you keep going with your physics journey. Thanks so much for joining me for this explainer today. Keep asking those awesome questions, and I'll catch you next time.